Before watching this video, please make sure to attempt this problem on your own. In this video, I'm going to go over how to answer the bold questions in the Canvas page that you need to answer in order to go through this problem. So let's start out with the information that we have in this scenario. So let's say that we are interested in understanding the relationship between eating pizza as our exposure and heart disease as our outcome variable. We know that pizza isn't often the healthiest food to eat, so we might hypothesize that people who eat pizza are going to be more likely to have heart disease. So let's say that I went out and I conducted a case control study to try and answer this question. The first thing I need to do is calculate my crude measure of association for the relationship between eating pizza and having heart disease. Given that this is a case control study, I know that I need to calculate an odds ratio. So to calculate the odds ratio, you would set up the information that's been given to you in the problem in a 2x2 table, which is displayed here. You can see that those who ate pizza are here on the exposure, and the cases and controls are here at the top, and I've plugged in those numbers. When you calculate that crude odds ratio, that would come out to 23. So if you didn't get a calculation that equals 23, make sure you're calculating an odds ratio and make sure you've got those numbers plugged into the right spots. But this is my crude odds ratio. It's a really large odds ratio, 23. We don't often see odds ratios that big in the literature. Now we might want to think about whether this is a valid result. So thinking about this finding, should I then just conclude that 23 is the odds ratio that we should accept? We might want to think about a variable or variables that could potentially confound that relationship. And so thinking about potential variables, I might be concerned that drinking beer could be a potential confounder. I might think about this variable in particular because based on the previous literature that I know that drinking beer has an association with eating pizza, and drinking beer, alcohol consumption, is also associated with having heart disease. Now, unlike the previous example we went through in the module, I am assuming that this meets the characteristics of a potential confounder, not by doing any calculations to see if there's actually an association with my exposure and my outcome, but rather based on the literature and previous knowledge on other studies. I know that other studies have shown that there's a relationship between drinking beer and eating pizza, and drinking beer and having heart disease. So based on the previous studies, I know that these associations exist. Not all studies are going to actually calculate the relationship between that potential confounder and the exposure and that potential confounder and the outcome like we did in the gender and malaria example. In this example, we're just going to assume that it meets those characteristics based on the previous literature that I'm familiar with. And I also know that drinking beer is not on the causal pathway between pizza and heart disease. Pizza does not result in the biologic consequence of drinking beer. That wouldn't make sense. So I know that it meets those characteristics of being a potential confounder based on the previous literature that exists on this topic. So given that I am concerned about this drinking beer variable potentially confounding the relationship between eating pizza and heart disease, what I want to do is I want to conduct a stratified analysis. So when I conduct a stratified analysis, I should be calculating the measure of association between eating pizza and heart disease just among those who drink beer, and then I should do that separately for those who don't drink beer. This is strata 1 of my potential confounder, so the first value of that drinking beer, and then this is strata 2, so those who don't drink beer. What you need to do is calculate those two measures of association. Given that this is a case control study, I need to stick with calculating an odds ratio. And when I calculate those odds ratios, I get odds ratios of 9 for the drinking beer, and I also get an odds ratio of 9 for the not drinking beer. These are very similar to one another. In fact, in this example, they are the same. So that's kind of the first flag that tells me that I could potentially have confounding. Those strata-specific measures should be really close to one another. In fact, they're actually the same. So now I need to calculate an adjusted measure of association. So my strata 1 odds ratio is 9. My strata 2 odds ratio is 9. Therefore, my adjusted measure of association, that in terms of that relationship between eating pizza and having heart disease, adjusted for this drinking beer variable, that is also going to be 9, because I'm going to take basically an average of my strata-specific measures. So the average between 9 and 9 is 9, and therefore I can conclude that my adjusted measure of association is going to be 9 for the relationship between eating pizza and having heart disease, adjusted for that drinking beer variable. Now, to determine whether drinking beer actually confounds the relationship between eating pizza and heart disease, I need to compare the crude and the adjusted. So remember, you're going to use that formula. You're going to look at the crude odds ratio, you'll subtract the adjusted odds ratio, and then you'll divide that number by the adjusted odds ratio times 100% to see that percent change. If it's greater than 10%, I would conclude that, in fact, that variable is a confounder. So what this essentially looks like is I've got my crude of 23, my strata-specific measures that are 9, my adjusted odds ratio of 9, and when I plug in those numbers to that formula, I see that I get a percent change of 155%. That is obviously way more than 10%. Therefore, I would conclude that drinking beer is indeed a confounder in the relationship between eating pizza and having heart disease. So it's a confounder. When I think about trying to communicate to people what the takeaway overall result is, how would you describe the relationship between eating pizza and heart disease? Well, I wouldn't say that the odds ratio for those variables is 23. In fact, what I would say is that the odds ratio for the relationship between eating pizza and having heart disease, the odds ratio is 9. That's because the crude measure is confounded by this drinking beer variable. Therefore, the results that I want to report as my overall key takeaway, I want to report this adjusted measure of association because I have confounding. If I didn't have confounding, let's say drinking beer was not a confounder, then I would just report the crude measure of association as my overall takeaway results. But in this case, I do have confounding, so I need to report that adjusted measure of association. And so if I were to describe that association, I would say it's a positive association. I have an odds ratio of 9.